where we were trying to find the time, the missing time. So here's what we give you, the world population in millions. So make sure you understand that these values are in millions. And they give you the values from 1998 to 2007. And they say an exponential growth model, so they've gone and calculated the formula here. If you'll notice that this initial value is 5,400. Now in our chart, in 1998, our initial value is 5,930. So if we say the time is from 8 to 17 years, what would be time of 0? That's 8 years prior, so I'm just going to go ahead and write that down. In 1990, 8 years ago, the initial population was 5,400. So I like to write that down. So they go and identify all the population values in millions for that time period. And then we just showed you the graph here, okay? What we want you to do is to find out when will the population reach 6.8 billion. Now notice this is in a different units, not in millions. So how do you convert from a billion? So we're going to switch it now to millions. So remember, you move that 3 decimals to the right. So it's going to be the same as 6,800 million. Okay. So what time will this be? So this is our population. Our unknown is our time in years. So we're going to use our formula up above in the blue. 5,400 E 0.011852 T. All right, so we're going to go ahead and put our population in. 6,800 really represents 6,800 million. 5,400 represents those in millions. And what we want to do is we want to solve this equation for T. So we're going to undo. So the first thing we want to undo is we're going to divide both sides by 5,400. So we can try to get that E part by itself. So those are now gone. Now I have 6,800 divided by 5,400. And I have E raised to the 0.011852 T. Now when we try to solve an equation that has an E in it with an exponent, we can go ahead and multiply both sides by the natural log. Do that to both sides. And the benefit to that is, if you remember, the natural log and base E exponential are inverses of each other. So we're left with just the 0.011852 T, and then on the left, nothing has changed. All right, we're almost there to solve for time. We're going to go ahead and divide both sides by that decimal value. Those will cancel, and then divide it by 0.011852. Be careful when you enter this into your calculator. Go ahead and take the natural log of 6,800 divided by 5,400, finish off that parentheses, and then divide it by 0.011852. And then what you're left with when you enter that in your calculator is 19.4. What that represents is, remember when we had time of 0 back up here in our chart? When our time was 0, we were at 1990 with an initial population of 5,400 or 54 million there, 54,000 million. All right, so when time is 0, we're at 1990. That's why I like to find the initial time. Now, 19.4 years later, what time would that be? So I'm going to go ahead and just add 19.4 to 1990. And we get the year 2009. that's when the population will reach 6.8 billion people in the world.